Okay, let's use this mean value theorem with some examples. All right, so let's say, for example, the function f of x equals 1 over x, and we want to look at it in a closed interval from 1 to 3, find the following. Let's find the average function value. So there's our formula, 1 over BA integrated from a to b of f of x dx. So 3 minus 1 will be 2, so that'll be a half. We'll integrate it from 1 to 3 of 1 over x dx. All right, so that will be, if you recall, your integration of 1 over x is just the natural log of the absolute value of x. We just have to make sure that those numbers are going in and are going to be positive. Well, we're going from 1 to 3, so we don't need the absolute value of ours. We integrate this. 1/2 times the natural log of 3 minus the natural log of 1, but wait a minute, the natural log of 1, that's the value of 0. So our average function value is 1/2 natural log of 3. If we wanted to look at a decimal representation, it's approximately 0.5493. All right, find C such that f of C is equal to this average function value. So in other words, f of C equals 1/2 the natural log of 3. Okay, well, if I put C into my function 1 over x, so that's going to be 1 over c equals 1/2 natural log of 3, we're going to go ahead and we're going to solve for c. Well, I don't like fractions, so I'm going to take this 2, multiply it to the left, take this c, multiply it over to the right, and so 2 equals the natural log of 3 times c, and to solve for c, just divide the natural log of 3 into the 2. So my C value, this is the exact value. If they wanted a decimal representation, it's 1.8205. Part C, okay, here comes the graph. Graph F and the rectangle whose area is the same as the area under the curve. So if you wanted to go to 1 over x and get some points, here's my curve. I have a point at 1, 1. And then you can approximate the natural log of 2 as a decimal, the natural log of 3, maybe the natural log of 2/3, the natural log of 1/3. Here's my curve. But we're looking for this area under the curve from 1 to 3. That's this area. We'll call that in blue or turquoise, whatever you want to call it. Now, the rectangle's area, all right, now we're going to take that natural log of 3 over 2, that's my C value right here. Okay, that's going to be my Y value. That's going to be the height of my rectangle. Okay, so that C value creates this value right here. So my C of 1.8205, or 2 over the natural log of 3, is the location between 1 and 3. My average function value, that's the height of my rectangle. So this gold area matches the exact same area as what's in the blue area. All right, another example for the function f of x is equal to 2x over 1 plus x squared, all that squared, on 0 to 2. Find the same three things again. The average function value, we'll find the c, and we'll make the graphs. So my formula, 1 over b minus a, so 2 minus 0, that will be a half. Integrate from 0 to 2 of 2x over 1 plus x squared squared dx. Okay, we need to do a u substitution here. 1 plus x squared, that's going to be my u. And I take the derivative of that. Well, the derivative of 1 is 0. The derivative of x squared is 2x, which happens to match my numerator. So I have everything I need, except we're going to change the boundaries. So my upper bound of 2, if I put that in, that will become a 5, and my lower bound is 0. Substitute in for x will become a 1. So when x is 0, u is 1. When x is 2, 1 plus 2 squared, or 4, is 5. So now it's 1/2 integrating from 1 to 5 of 1 over u squared, or, if you will, u to the negative 2 power. Let's integrate it, add 1 to that, divide by negative 1. Dividing by the negative 1, I just moved it out to the 1/2, made that a negative. Then I'm going to change my u back to 1. U to the negative 1 is 1 over u, so that becomes 1/5 minus 1, which becomes a negative 4/5. All right, negative times negative is a positive. 2 goes into 4 2 times, so I get 2/5. There is my average function value. So for part B, just like we did in the previous example, f of c is equal to 2/5. Take the function, replace f of c, and now we solve this for c. So because it's a proportion, I'm going to cross multiply, so 5 times 2c will be 10c on the left, and I'll have 2 times the binomial 1 plus c squared, all that squared. Well, we're going to make things a little smaller. Let's divide over the 2. I don't like to work with big values. Let's go ahead and FOIL this out. That will be 1 plus 2c squared plus c to the 4th, or if you prefer to put it in descending order, c to the 4th plus 2c squared plus 1. We'll subtract over the 5c. Really can't combine it with anything. I can't factor this. This is really ugly. So to find my c value, I'm going to have to go to my calculator, type that into y1, graph it. Because it's set equal to 0, I'm looking for these x-intercepts. So we'll do the 0 command. Second trace is 0. Go between 0 and 1. That's this value. Then we'll go between 1 and 2. That's this decimal value. So there's my two c values right here. So part C, graph f and the rectangles whose area is the same under the curve. So again, probably go to my calculator, get a picture of this function here on my calculator, and I matched it up. It's really close to the x-axis, so I kind of zoomed in, if you will. I changed my window from 0 to 2, and my y went from 0 to 1, and I counted by 1/5 or 0.2, and that spaced it out a little bit better for me right there. So 2/5, that's why I counted by a fifth. My y is 2/5. It crosses the graph in 2 locations. This is the first c value of 0.2198. Here's the second c value, that 1.2068. This area here in gold is the same area that would be under the blue curve from 0 to 2. And that wraps up our 7.5.